Okay, everybody. This little video is to kind of show you guys how I figured out last night's homework. I chose to do problem number 7, and this is letter A, question A on problem number 7. All right. First things first. What I always like to do first is to get my variables laid out for me. So N, number in the sample population, 753. P, the probability is 3.5% or 0.035. I don't know why this little one's there, but yeah, it's 0.035. Anyway, so my population mean is equal to N times P, so 753 times 0.035, which equals 26.36. My standard deviation, which is equal to square root of N times P times Q, and we already know what N times P is, 26.36 times 0.965, because Q is 1 minus P, which that gives you 90.965, equals standard deviation of 5.04. And then X, which is going to come in handy in when you're finding your the Z-score, which we'll do here in a second, is actually 14.5 and not 15, like the question actually says. And the explanation basically is given to you on page 275. And because under a normal approximation, the bar that encompasses 15 actually starts at 14.5. So you want to use the number of where it starts. Just read page 275 and look at figure 6-34, and it should help you figure it out. Anyway, so basically what we're wanting to find out is a probability that number greater than or equal to 15 will live to be beyond 90 years old. So basically, with that, you want to find a Z. You start finding your Z score. Z equals 14.5, not 15, minus 26.36. Divide that by your standard deviation. Come on. I'm sorry, my tablet's a piece of junk. And that equals out to be negative 2.35, which the area under the curve would be 0.0094, which would be to the left of negative 2.35 on the curve. Because remember, you have your curve, or at least a version of it. And let's say negative 2 is here, so this would be less than. However, we want more than a number greater than or equal to 15. So basically, you want more. So you got what it's really asking for is probability of this area over here. So now all we need to do here is 1 minus 0.0094, and that equals 0.9906. So basically, that it's saying that there's a 99.06% probability that that 15 or more students will live beyond the age of 90 out of that class of 753. That's kind of how I solved letter A. If you have any questions, let me know. I hope this helped. I know it's kind of quick, but it's just kind of easy once you get down. You just lay out your variables and kind of all relate it to and know what you're looking for, and know your Z-scores. Anyways, let me know if you have any questions, and I really, really hope that this helped.